Hello my dear friends, this is lecture 371 in continuation of design of retaining wall. We have already designed the heel, so we will go for the design of toe. Now you see what is the downward pressure. If you neglect the some pressure, earth pressure that is very minute, so you can neglect that pressure, and total downward pressure will be the self weight of toe per running meter. The depth is 0.4, so this is 0.4 in 25, this is 10 kilonewton per meter square. Now we can draw the pressure diagram. Is already this 0.8 meter for 0.8 meter. This is 129. Previously we have just gone through, and this is your 89.16. So this is your 10 kilonewton. This is a downward and this is upward. So resultant will be 119, 10 घट जाएगा, and this is your 79.16. So these are the net pressure. This is your net pressure diagram. Now you can find out the shear. Shear is how? That is 199 into 0.8 divided by 2. This is average taken, and this is 79.16 divided by 2 into 0.8. This is average. This is because this is a trapezoidal, so we are taking this much off. So we are getting the one in 47.6 here and another in 31.7 kilonewton. Now you can find out the moment. Moment will be for first part and second part. First part 47.6 into half into 0.8. This is taken half because this is trapezoidal, so we are taking average half, that is may lie in the middle. So 47.6 into half into 0.8, and that is also this part is the shear 31.7 into 0.5. So we are getting 33.84 kilonewton meter. So we can find out D is equal to m QBD square, m equal to QBD square, so D is equal to m by QB. So you put the value Q 0.65, and this value you are getting 228 mm. Now D required, it is 400 width and 1040 cover, and 10 if you use 20 mm, if you use 16 mm, this will be 8. So 350 mm is required. So we will put 350 mm instead of 228. So AST will be m by sigma ST-JE, that is 33.85 10 power 6 230.9. This is your J, and 350. So we are getting 464 mm square. We can go for this 20 mm because from the stem the bar is coming, is bent and taken towards the 2. So you adjust this 20 mm. This is required 500 mm center, but that is if you put 250 mm, so alternate bar will go inside the 2. This can be managed, and distribution still you can provide 10 mm 5 something like that is 0.12%. 0.12% of the cross section can be break. Cross section is 400, okay, into 1000. This is your 0.12 divided by 100. So by this you can provide the distribution scale that can be provided. That is 10 mm 8 rate of something can be done. So this is a part of a moment, we can say. So let us check the bearing stress and all, the allowable pressure and all. So in the next you will try to visualize that pressure. So let's continue. Further provision of steel in toe. So what will happen? The main reinforcement is coming from this stem, that is bent. That will be bent to provide the reinforcement for toe. So the stem main reinforcement of 20 mm, suppose we have taken at rate 250 mm, center will continue in stem with bend and straight. So bend, far bend A is your spacing 250 mm center. Allowable bearing stress in inside bend क्या होगा? That is FCK upon 1 plus 25 upon A. So FCK is if you have taken M15 M15, then this is 15, 1 plus 2 into 20 by 250. So this is 12.93. If you take 20, this will be 20. So FBT R5, that is R is FBT, 1 permeable stress into 5. So we have put FBT is equal to sigma ST into AST 230 into area of 1 bar 20 mm. 3 is 14, 12.9, 20. So this is given 279. So bend will be R will be at 300 mm can be provided. So in this way we can provide the further T reinforcement. The distribution steel we can provide 10 mm at rate, and minimum shear we can check. You can check the shear stress also. So shear can be checked as usual. You can check the shear and check tau B and tau C, something like that. So this will be maximum shear, whatever be the shear with the cross section divided by B into D. We can get this value, that is 79.3. That is 79.3 into 10 to power 3 divided by BD 1000 into 350 correct. So this will be your value. We are getting this value 10 to power 3.225. So this is stress, shear stress. This is your, you can say 17.3 divided by 350. This is coming very much 0.226 Newton per mm square. 100 AS by VD you can find out. 100 AS by VD. So corresponding you go find out tau C. You will find out the tau C. 100 AS by VD. You can find out the tau C. So you can find out the tau C also, and you can compare. Tau C is sufficient, so need not to provide any shear reinforcement. This is you can find out this 116. So the process is same as we have done earlier. So we can always check the shear also, whatever with the shear that can be checked. So this is all about the design of your toe. And what is the key? Key you can provide normal. The key is the 450. This is 450 dimension. So take 0.12% of, you can say into 450 to 1000. So इससे जो भी आपका आ जाएगा, whatever be the value of AS, you can provide with some suitable spacing. जो मेन 10 mm की बार आ रही उसी बार के साथ इसको हम लोग कोरिलेट कर लेंगे, और ये मिनिमम स्टील को देख लेंगे कि इतना 0.12% जो है आपका वहाँ एंकर की में जो है आप प्रोवाइड कर दे रहे हैं. तो अब डायग्राम की मदद से हम लोग इसको विजुलाइज करेंगे कि किस तरह से रीइंफोर्समेंट का डिटेलिंग की गई है. तो विल कंटिन्यू फॉर द डिटेल. सो वी कैन अरेंज द रीइंफोर्समेंट. You see the main reinforced stem is this side where is a fill. So this can be 20 mm at rate of 250 center. So the curtailment is there at 2100 maybe whatever be. So this will be 50%. So spacing will be 500 center. The distribution is still on this side will be according to 0.12% of this thing. So we can have this 10 mm. This can be 10 mm at rate of 150 mm both ways can be done. This is 100. This is provided 10 mm. This is 10 mm. 10 mm 5 at rate of 150 mm. 8 per requirement, that is minimum 0.12% of the cross section. So this will continue in the bottom, and this bend is provided which we have calculated are 300 something like that. So this will continue at a spacing of 250 mm center to center. So distribution steel will be there. You can say the distribution steel is can be 10 mm pipe, that is which we have provided 150 mm, that can be provided over here. And the heel portion is 12 mm pipe main bar 150 center center, and distribution 10 mm pipe 150 mm center to center. This will continue throughout the from 2, and this is bottom part. You provide 10 mm, 300 mm both way can be provided. This will extend up to here, up to this point. You can extend up to length in that. And the far key, this temperature which is coming from this stem will continue over here. This will be your 10 mm, 400 mm both ways can be provided in the key. So the portion is, this is in tension. This is a tension portion, and this is tension portion. So negative reinforcement, main reinforcement provided, and here in the bottom is a tension portion. So we can provide the main reinforcement. So the main reinforcement at the bottom, at the top, you can say, and at the heel side. This is in stem. So this is the arrangement how you provide the reinforcement. That can be done by you, by some figure out. You can do it more precisely. So thank you for being with me for the design of returning one. Thank you very much.